this problem, I think the first one, which is I think simple, but let us start with some warm-up. This is the joint probability distribution given to us, a constant c divided by x to the fourth y, and then if this happens, and then of course 0 otherwise. There are things we want to calculate, so we want to calculate these conditional expectations. And the other one. Okay. So, okay, I'm hearing from you. So, what should I do first? First, probably you know what you have to find this c first, yes, because every calculation will depend on that c, and finding that c shouldn't be very hard. So, what is the idea? The integral of this over R2 should be equal to 1. So, from that condition, I in principle should be able to find that c. But of course, the support of this joint function is here. It's always good to draw some pictures. So if I want to visualize this support, this is x and y. So y equals to 1 is this horizontal line. Yes, this is 1. And then y equals to x is this angle bisector of the first and the third quadrants. Yes. Okay, so this is y equals to x. But which part is acceptable here? On the one hand, y should be above 1. So it means that when it comes to this horizontal line, I have to be above this line. On the other hand, y should be less than x. Y equals x is this line. So this region down there will be y less than x, and this will be y bigger than x. So I should be between these two. So I hope that you agree with me that if I want to respect both conditions, that will be the domain or support. Is that correct? Yeah, please interrupt me if there is something that you don't understand. Of course, if you know this is 1, you know this intersection has x coordinate also equal to 1 because that's just y equals to x. So that is my support. Okay, so I have to, and if you don't mind, let me call this support D. And then I want to calculate the integral. So I know that if I calculate this double integral over that support, this should be. Of course, in principle, I have to calculate it everywhere on R2. It becomes 1. But because this only survives on this part, so this will be coming to this domain. Okay. So then, how should I calculate? So f of x and y on this domain follows this rule. C is a constant. I pull it out, so it becomes c integral. So let me write the domain first, and then I have this function. And please interrupt me if there is something I am doing stupidly here on the board. Please do not wait until the end. And of course, if you don't understand something, please interrupt. Okay, so as we have discussed a lot in this course about calculating double integrals, first you have to make your mind about which variable you want to give the role of independent variable and which one you want to give the role of dependent variable. And of course, usually I myself prefer to give the role of independent variable to x. But I don't know if you have done this before, you realize that if I do this, I will be a little bit in trouble. Okay, so let us pretend that we don't know that, we won't believe it, okay? So if I want to do that, then what happens, so let me write x independent. Let us see if it works. If x is independent, so let me put this in a pair of brackets, and then of course I have to continue. This becomes c integral. I need to write dx here, and then I would write 1 over x to the power of 4y dy. Okay. So can you tell me what should I write for the limits, for the bounds here? I want to be my support, and I have chosen x to be my independent variable. So on my support, x will go from where to where? It starts from 1 and it goes to infinity. Yes, so it goes from 1 up to infinity. But for the second part, you have to assume that one single x is chosen. Okay, so what does it mean? It means that, for example, you have chosen one x on this range. So let me just visualize it here. This is my x. And for this particular x, I need to know what are the limits for y. Okay, so how should I know that? I have to go upward to have the cross section with my support. Yes, so it will go up to here. So that is the intersection. Okay, can you tell me the limits now? For this chosen x, the lowest y value is 1, but the highest y value is the x I chose, because it is this one and this is equal to this. Do you agree? Yeah. Okay, so but this, I hope that you can see I'm a little bit in trouble. Why? Because this one, if I want to calculate it, so it goes from here, and then let me write that. But if I want to calculate this, 1 over x to the 4th, because the variable of integration is y, is considered a constant. In your head, put it out. And then there will be 1 over y dy, and 1 over y dy is just ln of absolute value of y. So this becomes 1 over x to the power of 4, ln of, in principle, physicists write dx here, I'm just used to it, so you can put this dx there, okay? But then I have to run it from where to where? From 1 to x. And then I have to replace y with x, so it becomes ln of absolute value of x, but I do not need absolute value because x is positive, so it becomes ln of x itself. But when I put 1 there, ln of 1 is 0, so it becomes ln of x. Then I have to write c integral from 1 to infinity, and then I have ln of x divided by x to the power of 4 dx. Okay, so that's my advice. I mean, that was the way that I did it myself first. I was careless, and then I got this one. And this integral is, I don't remember it. It's possible to calculate, or at least it is very hard to calculate if it's possible. Okay, so whenever this happens, don't give up, because you might change the role of independent variable from x to y, it starts working. Okay, so that I just wanted to do it in that way so that we see that, okay, so this becomes a dead end. So this means that, okay, I will give this up at this point, not because it is wrong, because calculating this integral, if possible, is hard. But if I interchange the role of independent variable, it will work. You will see. So, but I want you to help me again. Okay. Now I want you to change the role of the variables. Okay. So how should I do that? So I will continue from here. So this becomes equal to c. Then I will write dy first, and then I will go for dx. Of course, the function is the same function, and then I have dx here. Okay, help me. So what is the role? What are the limits for y? But this time y is your independent variable. You have to be still in the support. So you are still in this support. So for that, what are the values for y? 1 to positive infinity again. So this becomes 1 to positive infinity. Okay, what about that x? This again means you choose one of these y values. So for example, let us say this is my y value. And then I go horizontally to intersect my support. Okay, so let me make this dotted line here. So this will be my cross section. Yes, and it will continue forever, of course. Okay, now can you fill up the limits? The upper limit is very clear. The highest value of x coordinate of this blue line is infinity, which becomes infinity. But what is the lowest value? Y, the y that I chosen. Actually, the lowest x value is equal to that y that I have chosen. So it goes from here to here. Okay, so you have to sometimes do some trial and error, okay? So then I think you can see that this is working this time. Because this I can write it as c integral from 1 to infinity. And then I am integrating with respect to x variable. So 1 over y. So let me write dy here. And then I would write 1 over y. Okay, can you do this one in your head? X to power 4, bring it up, x to power minus 4, so it becomes x to power minus 3 divided by minus 3. So it becomes minus 1 over 3 x to power 3. Then I have to run it from y to infinity. Yes? Yes. Okay, so if but be careful, I am replacing x with infinity, becomes 0, and then I replace x with y, it becomes 3y cubed times y, 3y to power 4, and this minus sign also goes away. So this becomes what? 1 over 3, so it becomes c over 3, and then I have integral of 1 over y to the power of 4 dy, but this time I have to run it from 1 to infinity. And this is extremely simple again, so this becomes c over 3. If you do this one in your head, this would be exactly the same thing. Yes, it becomes 1 over 3y cubed with negatives. And then I have to run it from 1 to infinity. Infinity is 0 plus c over Yes, always double check my calculations. It's good. It keeps you alert. The minus sign is gone because the first one I have to put is infinity. It gives me 0, but then minus, then I should that one minus minus plus. Yeah, but very good. Please check my calculation. So this means that what is my c now? Do you remember 1 is equal to c over 9? So this means that 1 is equal to c over 9, so c is 9. Okay, so let us tackle this question. This is my question mark, so I want to calculate this. What is the first thing comes to your mind as a mathematician if you want to calculate something? You need to think about its definition. So what does it mean? Okay, so what does it mean? So it's here integral y times f of what? Y conditional distribution, yes? Of y and dy. For any chosen x, of course, from your support, because if x is not in your support, I mean, if x is not greater than 1, of course, this becomes 0. Okay, so we want to calculate this. But again, your mindset is the same. X is chosen somewhere in your support, and you want to calculate this integral, and then you want to know what are the limits for y. You already know that. It goes from 1 to x. Yes? So this is what I want to calculate. So you see, this is the way I think. I want to tackle this question. I remind myself about its definition. Then I see that I have a new problem comes in. Yes? And the new problem is this one because it is not given to me. So I start from, this is the best way because some people, of course, know what is going to happen. They calculate things and then try to write very clearly. But this is the way you think. Of course, mathematicians write it upside down. Yes? So here you just write it, and then you see, oh, this is my new question to answer. So I have to answer this question. Again, the same strategy. If I want to answer that question, I have to remind myself about its definition. Yes? So what is the definition of that? This is f of x and y, and then divided by f, yes, you're right. F of x of x. Okay? And of course, they are actually deviating from the notation, so this is in principle means what is here? Excellent. Okay. So for some reason, of course, this is also in the book. For some reason in the exercises they are writing only like this, but this is what they do. So here, in order to answer this question mark, I need two things. This one I have, this one I need. So I have to calculate. So you see, in order to answer this question mark, you need to answer this question mark. In order to answer this question mark, you need this one. So this is the way you think, okay? But of course, that's up to you how you write it back. So this means that now I have to answer this question, right? Which is simple, yes? So this is very standard trick. So what should I do? Again, I choose one x in my support, because if x is not in my support, I already know the answer, which is 0. So I choose x between, I choose x greater than 1. So what is f of x? This becomes integral of the joint distribution function. If you don't mind, let me just write it f x and y, but I have to integrate it over the other variable. X is chosen. You already know what are the limits of y. These are the same limits, yes? But the logic is always the same. Okay, so let us calculate this one. So this becomes integral from 1 to x. Instead of f of x and y, I put that, but I also know that c is 9. So this becomes 9x to the power 4y, and then I have dy. Okay, so I pull this out, so this becomes 9x to the power of 4, and then this becomes ln of absolute value of y. I have to run it from 1 to x. If I put 1 is 0, so I just put x, and because x is positive, I really don't need the absolute value. Okay, so now I go back. So if I want to keep some star here, so let me put star here if you want to do it later. So here from double star, I can conclude what? I can conclude that f of, I can conclude that this is equal to this one divided by that one. That one I have, it is 9 over x to the power of 4y, then I divide it by this guy. So 9 ln of x to the power 4. So if you simplify that, it becomes 1, this 9 gone, this is gone, so it becomes 1 over, is that right? So this becomes f of y on the condition of x, and then everything is ready, so I go from 1 star to finalize my problem, yes? So what is y star? What star I here? Integral from 1 to, so this means that e is equal to the integral from 1 to x, and then I have y, and then I have this expression which I found there, and then I have dy. But this is simple because this y and that y are gone. Ln of x is considered a constant here because this variable is y, so I pull it out. Integral of dy becomes y from 1 to x is x minus 1. Yes, do you agree? And it's also good to check the answers. I don't remember. But of course, if x is greater than 1, if x is less than 1. Any questions? If you don't mind, we can skip this. I think you can do this. This is the other way around. Yes. Is that okay? If I skip that? Yes. So, any questions? The next problem is a little bit more interesting. So, this is problem problem 2633 from the course book. This is a little bit nicer. Suppose that the random variable x is uniformly distributed symmetrically around 0, but in such a way that the parameter is uniform on an interval from 0 to 1. Of course, they have written what they mean exactly. Then they have written, that is, suppose that this random variable has uniform distribution from minus a to a, and we also know that a itself has uniform distribution on the interval from 0 to 1. We are supposed to find a distribution of x, so which I write fx. This is what we want to calculate. We also want to calculate p of x, expectation value, and the variance of x. Okay, so how should we do this? Can you first, you need to understand exactly what these things mean, and you have enough experience here. Let us start with simple. So how do you translate this into mathematical language? So A is uniformly distributed. So if you don't remember this, you need to check it out at the end of the book, but I have it in my memory. So can you confirm what I am writing? I'm just using my memory, okay? That's not something extreme. Yes? Can you confirm that this is the mathematical translation of this information? Yes? Okay? Now, how can I translate this? This means what? This means something is equal to this uniform distribution. What can I write? It's 1 over this number minus that number, a minus minus a to a, where, sorry. That's not good. Yeah, that's right. But I want to zero otherwise, but I want to wait for you to fill it up for me. What should I write here? What should I write? Because this is the first step. If you have trouble translating this, then you cannot even go forward.
When x is between.
So, what should I write here? A. So, in principle, I have to write x between minus a and a, or as you said, absolute value. That's okay. But what should I write here? F of
x given a
as a function of
x.
That's it. So these are the translations of these two pieces of information. Yes? Okay. And then I want to calculate this one. How do you think about the problem? So I want to calculate f of x. You have an immediate experience from that problem somehow. You want to calculate the marginal distribution of these. How should I do that? Yes, it might work, but I just want to use the formula as much as I can. Okay. When you want to, if you want to know this, what is the standard way to calculate f of x? Then you have in the problem more than one variable. I have more than one variable, more than one random variable. Two. One of them x is one random variable, a is another random variable. So I have two random variables, but I want to find a marginal function for one of them. This is a standard trick. So if I want to go from 2 to 1, I need to know the joint probability distribution. Is that right? So if this is the way you need to think, these problems might not be that hard, but if you think not correctly, you will be in trouble. So when I see the problem, because I have this standard trick in mind, so I will look for f of x and a. So the first question, I'm not saying this is the only way, as you said, you can solve it differently, but the first thing comes to mind for me is if there is any way for me to calculate this. You see, this is the way I think. I tell to myself, if I know this, then I know how to do it. Because that is just one integration with respect to the other variable thing. So that's my question. But now, how can I answer this question? I see that I have two pieces of information. I know about A, I know about this probability distribution, this conditional distribution. And then the formula is on the board, yes? Yes, because if in this problem, this is given, this is wanted, this is also given, and that up there is wanted. That's the same formula written the other way around. So that's the way I think, okay? So what I will do, I will write the formula. I would say that fx a equals to a of x is equal to what? Is equal to f of x and a, and then x little a divided by f of a. That's it. Do you agree? So now you see that this one is given. Where is it? Here. This one is also given here. Yes. Here. And this one is one. Yes. So let us do that together. So this means that f of x, and a is equal to f of x, a equals to a x multiplied by f of a. Okay? So how should I multiply that? Of course, most of the time this product is zero. This product is not zero only if this is respected and that is respected. Okay? So this means that this becomes equal to zero most of the time. So let me write otherwise. Otherwise from what? From respecting two conditions. One condition on A, one condition on X. And then this function is 1, this function is 1 over 2a, I multiply them. So it becomes 1 over 2a. On the condition that a is somewhere between 0 and 1, and x is between minus a and b. So you see you found it. Okay? And now, this is very standard problem. You want to go from that joint probability distribution to marginal one. So you have to integrate over the other variable. It's a standard trick. But I want to see if you are confused or not. Okay, so I want to calculate. First, let me write the formula. This is one thing, the first question. So what should I write? I should integrate over the other variable. This is my joint probability distribution. I have to integrate it over the little bit. Okay? And then you have to fill it up for me, the limits. For a, so x is fixed. Okay? But be careful, x is fixed in your support. The first thing comes to mind, if you can do it without drawing any pictures, of course you can do it, but I always try to visualize, you know. So how should I visualize? So what are my values? First of all, let me see if you are with me or not. I want to draw a coordinate system because I have two variables. One of them is a, one of them is x. So what should I name these axes? Axis of a and axis of x. Is that right? Because I have two variables. So let me, I don't know, it doesn't matter that much. Let me call this a axis and let me call this x axis. Then you have to find your support. So your support is a equals to 0, a equals to 1. A equals to 0 is this x-axis. A equals to 1, let us imagine that this is 1, this is this axis. This is this line. Yes? But where I am now, I am between 0 and 1. So I am in this strip now. But after that I am in this strip, I am also having these two. So how should I draw this? X, I want to visualize minus a less than x less than 1. What should I do? I want to wait a little. A is playing the role of normal x. So that is, this is y equals to x, y equals to minus x. Okay, but I have used a for x and x for y because that was in the problem. So that's important. When I say x equals to a, you need to draw this line for me. X equals to a. Yes. And then if I say x equals to minus a, you have to draw this line for me, this the other bisector. Okay, but tell me first, okay, let us do that later. But which part is acceptable? So, on the one hand, I was in this strip, but x should be less than a. This is x equals to a. On this side, x is greater than a, so I have to be below. Yes? On this line, x is equal to minus a, but x should be greater than minus a, so I should be above. So, and then of course you have to be on this side, you have to be on this side. If you consider all cases, I think you understand that this is your support. Yes? And if that's my support, can you tell me what is this height? What is this value here? 1. And what is this value? Minus 1. Why? Because this is 1, and this is x equals to a, this is x equals to minus a. So that's it. So that's your support. And then you have to, you immediately understand what happens. If x is not in my support, if x is chosen so that I am not in the support, means that if x is less than 1, less than 0 or greater than 1, it is 0. So I am only interested in which part? If x is between 0 and 1. Okay? So you have to pretend that x is chosen between 0 and 1, and that is your x. For that particular x, you need to write the limits of a. Okay? So I want you to do it for me. Okay, so this becomes integral. You know what to do here. This is your function. Yes, and then dA. Okay, but can you help me to write the limits? Because that's the most important part of it.
Minus 6x.
What? So x is chosen somewhere between 0 and 1. So in your head, fix it. This is your x. And then I told you, look at the vertical cross section here. So this is your cross section of your support. For this x, the lowest a value,
X is
oh,
the
sorry.
other
Yes. X is some, okay, so I have to calculate it in two different ways then. So I was a little bit careless, yes? Because x can be between 0, x is somewhere from minus 1 to 1. That was my mistake, sorry. But anyway, you have to divide it into two parts, so that was just a coincidence, you know? Why I have to do it? Because it depends. If I choose x somewhere here, then if I want to look at the y values, the a value go from here to here. But if x is chosen somewhere here, it goes from here to here. Yes? And of course, the right limit is always 1, but the first limit depends on this area. If I am choosing it somewhere here, it goes from minus x to 1. But if I choose it here, it goes from x to 1. Okay? So that is one motivation that let me divide it into two parts. That was accidentally correct. Okay, so what should I write here now for x between 0 and 1? What? I would write it from
Absolute value
x up to 1. Yes? This is what we write. But if x is between minus 1 and 0, then what happens? It goes from minus x to 1 again. Do you agree? Okay, so now every one of them is simple to calculate. This is just 1 over 2 ln of absolute value of a. I have to run it from x to 1. Yes? So what is the answer here? It becomes 1, ln of 1 is 0, minus ln of absolute value of x. Of course, here I can also move absolute value because I know x is positive. But let us keep it, it doesn't hurt. But this one will be the same primitive function, but I have to run it from minus x to 1. if I put 1 again, ln of x 0, so it becomes minus a half ln of absolute value of minus x, which becomes absolute value of x again. Yes, do you agree? Okay, so in principle, if x is between 0 and 1, or x is between minus 1 and 0, then this means that f of x x is equal to minus a half ln of absolute value of x. Of course, if that is not the case, this will be 0. But if you look at the faucet, they have written it in this way. Might be it's a little bit problematic for you first. By the way, this is common in probability, you know. They have written it like this. A very small deviation from what I got here. So what's the deviation? This is the answer in the faucet. From minus 1 to 1. So this is what we got here. First, I was also thinking that might be that's a misprint or miscalculation. Do you know why you should doubt a little bit about this answer?
Because 0 is good.
Yes, because if x, this tells you that f of 0 is acceptable, but on the other hand, we know that what happens if ln of 0 is not defined. Okay. I don't know how you want to think about it. If you really want to be very strict, that's no problem. But you need to remind yourself about what is the definition of x, f of x, x. If you take that definition into account, might be the answer in the book is not that bad. So what was that definition for a continuous random variable? Have you ever seen somewhere about boundedness of this function? It hasn't been mentioned, yes? So the function might be bounded. There are two main conditions for the marginal distribution function, or just, what is that? Two important conditions, I mean, by definition. Okay, come on, say something. What are the important properties of f sub x? Yes?
To be positive.
Non-negative.
Non-negative and integer
to 1. It's non-negative. Even if it goes to infinity, and what type of infinity is that, by the way? If it is negative infinity, I am in trouble, because this should be positive. But is it positive infinity or not? If x goes to 0, first of all, the existence of this absolute value is crucial. So this means that it doesn't matter if I calculate the limit of minus a half ln of absolute value of x. If I approach to 0 from the right or from the left, this becomes minus infinity, but because of this minus, the answer becomes positive. So yes, it is non-negative. And the crucial thing is you have to convince yourself that if I take the integral from minus infinity to infinity, it becomes 1. So even if the function is a little bit ill-defined, but it respects these two conditions, that it is non-negative and its integral is always 1, you can consider this as a well-defined marginal probability distribution. Okay, that's up to you. If you like this, you can keep it, but if you don't like it, then you have to write it the way that I do. Okay? But this you have to convince yourself. How should I convince myself? I have to integrate of this function. So I just tell you how to do it. So the left-hand side, so let me put a star here. So left-hand side of star is equal to. So first of all, can you see that I can limit it between where and where if I want to calculate this one? I am putting this answer in the book here. So this becomes integral. What should I write? From minus 1 to 1, because otherwise it is 0. And then I have a minus a half, I pull it out. And then I have ln of absolute value of x dx. Yes? And I have to convince myself that this calculation gives me 1. If it gives me 1, it means that what they have provided is good enough. But if I want to calculate this, I break it from -1 to 0, because I have to get rid of absolute value first. Between -1 and 0, what happens? Oh, by the way, I don't do that. There is a better way to do it. Can you see that? What type of function is this function? Whenever you have symmetry around the 0, you need to think about oddness or evenness. So ln of absolute value is even. Yes? So I can make it simpler. Instead of going from -1 to 1, I can multiply it by 2, but I go from 0 to 1. When I multiply it by 2, this minus a half becomes minus, and this becomes integral from 0 to absolute value of x dx. But the good news is that, do I need absolute value now? No, because x is positive. Yes? How can I calculate this? Do you remember your calculus? What type of technique is needed here? What?
Improper.
Yeah, it's an improper integral. Yes, you are right. So in principle, if I want to be very primitive, I have to write from epsilon. So minus, I put a minus here, epsilon to 1, and I have to send epsilon to 0 from the 1. But no, I was talking about how should I calculate the integral.
Partial integration?
A partial. It's called integration by part. Partial integration is the other one, which is fraction. That's integration by parts, but I have it in my memory, okay? So this becomes the minus of limit, so you need to trust me on that, but this should be a very simple exercise for you. So this becomes x, ln of x minus 1, minus x. Yes, but I have to run it from epsilon to 1. Okay, if you calculate this, then you will see that considering this minus sign, finally everything becomes 1. So that's a good answer. So what they have written in the book, if you consider this level of explanation, it's good enough. But if you don't like it, then of course you have to exclude 0. Yes, but then there will be another problem. Do you know why we cannot exclude 0? We have to define it some way. Why? Because by definition, little f of x domain should be the whole R. So you cannot say that, no, I don't define it for the whole R, I just define it for these numbers. You have to define it for everything. So in principle, what I have written is wrong, because people might ask, okay, bAbAk, you have to decide about what happens to 0. You cannot just put it under the rock. Yes? That's why, if that's a probability course, I think we have to exclude it. Because if we exclude 0 from it, it means the domain of my function is not the set of R, but it has to be by definition. Okay, any questions?
So you would say that a probability function for 0 is 0?
No, I would say that if x 0 is infinity. There is nothing I can say, that's it. Okay. You know, because what happens at one single point is not that important for the value. It's like have you heard about Dirac delta function in quantum mechanics? That's something like a peak value. Okay, so now we go to E of x, which is very simple now. I think in a matter of minutes we can do that. So what should I do? Yeah, please do these calculations. Yes, you should be able to convince yourself that this limit is 1. Finally, after putting epsilon on 1, of course. So, I need to calculate expectation value of x, which I don't even know why they have given this. Very simple now. So what should I write? I have to write f of x dx. And then I have my support, which is from -1 to 1. And sorry. What is the mistake by this formula? There will be an x. That's the mean. Okay, so let us write it. So integral from -1 to 1, I put x multiplied by -1/2 ln of absolute value of x dx. What is the result? Yes, 0. I just told you, whenever you have symmetry, think about oddness or evenness. What type of function is this function now? Odd. Why? If I change x to -x, this part will not change, but this part will pick up a minus sign. So I will pick up an overall minus sign. So this means that the function is odd. If the function is odd, and this is symmetric with respect to 0, the answer is 0. And then I want to calculate the variance of x, that's the definition. Okay, so what happens here? This one is 0, because we just calculate. I have to calculate this one. So it goes from -1 to 1. But the only difference is that I will have x squared, f of x dx. Yes? And then I calculate, so it becomes, so if you don't mind, let me put this minus a half out. Integral from -1 to 1 x squared ln of absolute value of x dx. Okay, so what should I do here? Symmetry again, but this function is unfortunately even. Yes, so I can simplify it a little bit. Do you agree that I can write minus instead of minus a half, but I should go from 0 to 1, and then do I need absolute value now? Yes. And then how should I calculate this integral? Of course, this is also improper, but I have to take a limit later. By the way, is it improper or not? I made a mistake. Is it improper? I'm just reviewing things from calculus. Is this an improper integral? Not. Why?
I had that exercise once.
Okay, that's a good explanation actually, especially for the exam. This because what is the meaning of an improper integral? We have two type of improper integrals. One is the one that the range, the interval is unbounded. That is easy to detect because you see infinity there, minus infinity something. Okay. But the other one is that the function becomes unbounded on that interval. Okay, not defined. Of course, I agree with you that you have a little bit of trouble when x is 0. That is not an indication that is an improper integral. An indication is that this function becomes unbounded when I approach to this problematic limit. But no, the limit of this function is bound. That's not an improper integral, of course, at the end. Okay? But then if you want to calculate it, how should I calculate this? Huh? Integration by parts is probably the best one. So which one you prefer to take? You remember the formula? Integral of u dv. I know this version of it. Minus integral v du. Okay? So I take this one to be u. And I will take this and that together dv. Yes? And I calculate this. So what happens? Let us calculate just this integral. Integral from x squared ln of x dx. So it becomes, according to this formula, if u is this one, and so let me write, u is ln of x, so du becomes dx over x. And then what do I have? I have x squared dx is dv, so v becomes x cubed divided by 3. So I put this in the formula, u times v, u times v, yes, minus integral v times du. V is this one, times du is this one. So it becomes 1 over 3 goes out, and then what happens? X to the power of 2, yes? Okay? But I want to use, first of all, there is a minus sign, be careful. So I put an overall minus sign here. And then I run it from 0 to 1. By the limit, of course, I run it from 0 to 1. This is called the boundary term, yes? So what is the answer to this? If you put 1, it is 0. And if you calculate the limit of this, it is a very simple path. You use Hubitel's rule. Yes, it is 0. And then you calculate this. This minus will cancel that minus. So it becomes what? 1 over 3. And then this becomes x over 3. And then you go from 0 to 1. So the answer becomes 1 over. Yes? Okay, so if you want to have a rest, let us have for 5 or 6 minutes now. And then we continue. Yeah, let me write it. Okay, so we want to know that, we know that no matter what n we choose, x is some random variable, so that when I raise it, I don't even know if it is continuous or discrete. It's not mentioned here, okay? So, and then they told us that expectation value for every natural power of your random variable is the same constant, not different constant, the same constant. Now you want to find out, okay, can you guess what is the distribution of that random variable? So if you haven't studied this chapter, might be it's a little bit horrible question, you know, because there are a lot of things to consider. How should I imagine that this is going to happen? Okay. But you have some clue if you have studied that. So for example, what will be going forward? Okay, so at least that level of rigor is probably enough for you. But for these cases, we can do it more rigorously. So what is this called what is the name of it in probability? E of x to the n? I just want to give you some hints. Yes? What is this called in English or in Swedish? Yes?
Expected value.
Expected value. But expected value of x to power n has a separate name. It's very important, by the way, you have to respect terminology. It's called the moment. And I just told you we have 3 functions. The first one is what? Probability generating function. The second one is? So it should be related to that one, not the first one. That's why names are extremely important. They're just not random sounds that we put on things, you know? Okay, so first of all, you need, so it means that either I should work with this one, this is called probability generating function, or I have to work with this one, which is called the moment generating function. So which one you start in this problem? If you start from here, you have a pre-assumption. What is the pre-assumption for probability generating functions? It's discrete. Okay, but we do not have that idea here. So we don't know any piece of information regarding if it is discrete or this one. So I have to start with this. And then, of course, whenever you want to start with something, you need to know the definition of that thing. So what is that thing? How is it defined? Do you remember? Let us review. What is this function? This function is an expectation value, but expectation value of which, this is your random variable, regardless of if it is continuous or discrete, it works. And then it becomes expectation value of Euler number to the power of t is this t, multiplied by your random variable. This is the definition, so let me put semicolon. Okay, let us talk a little bit about how it generates. So let us calculate things. And so instead of this one, what can I write? I can write sigma. Let me write n goes from 0 to infinity. And then I want to write what? T x to power n divided by n factorial. But then I can write it as e okay, so it is common that people separate 0 from the rest. I will tell you why, but let me also do the same thing. Okay, let me not do it. So n goes from 0 to infinity, and then this becomes t to power n divided by n factorial. But then you see that this x to power n appears here. Okay, so I want to be a little bit sloppy here. Of course, you know that e is a linear function, so it can go inside, but this is proven for the finite sum. This is an infinite sum. Whenever you have infinite sum, you have to be worried about. But let us not worry now.
hopefully you have seen these things in the exams, in your lectures, so this becomes that. Yes?
So E of a sum is sum of the E's. But these are constants, so I can pull them out. So this becomes what? Sigma. N goes from 0 to infinity. At least this way you will never forget the calculation. So this becomes t to the n factorial, and this E will apply here. Okay. And this is common. People separate 0 from the rest. If this sum goes from 0 up to infinity, let me calculate the 0, 1 itself. If I put 0 here, this becomes 1, this becomes 1, this becomes E of 1. E of 1 means that I have a random variable whose output is always constant 1. So it becomes 1. So this means 1, and then I have sigma, n goes from 1 to infinity, the same thing. So that's a very important formula. Yes? So what does it mean? It means that this moment generating function is closely related to moments. Yes? If you know the moments, you know the function. If you know the function, you know the moments by uniqueness of the power series. Yes? Okay, but now let us go back to this problem. So if I know that E of xn is C, so what should I do? This means that now this is the general problem. I should have written it with a different color. This is not part of the solution. This is in your book. Okay? But now I want to solve the problem. To solve the problem, I use the assumption. So what can I write? I can write for the problem. For the problem, I can write that psi x of t is equal to 1 plus sigma n goes from 1 to infinity tn n factorial multiplied by this constant c, because all of them are equal to c. And because now it is a constant, I can pull it out. So this becomes 1 plus c sigma n goes from 1 to infinity t to the n divided by n factorial. Okay? So this is an infinite sum. But the topic of this course, if you have done some exercises, you know that most of the time it is possible to bring it back to a closed formula. So you need to have a good understanding of infinite series. So can you see how can I write it as a function, as a closed form of function? That is the only thing you have to learn. So is this sigma familiar to your eyes? It is what? Exponential, but there is one problem with this exponential. The real exponential series starts from 0, but it starts from 1. And you have enough experience to engineer these things, yes? So what I can do, I can write 1 plus c, yes? And then instead of that one, I change it from 0. But I cannot do something out of the blue, yes? It starts from 1, I have to compensate for that. So what should I do? Minus what? 1. Are you with me or not? Because if I choose 0, the first term is 1, which was absent there. But when I start from 0, I have to subtract 1 to compensate for that change. Okay, but now can I continue now? This becomes 1 plus c. What is this function? E to power t, and this is minus 1. Do you agree? This you have done, and let me simplify it a little bit for you. So, for which values, by the way, because this is important to talk about convergence of series as well. But you know that this series is always convergent regardless of the value of t, because its radius of convergence is infinity. So I don't have any problems with convergence here. So at the end, I got this one. So psi x of t is equal to what? 1, let me multiply c in, and then plus c e to power t. So this is the first part of the problem. So based on this piece of information, I was given this.
Okay, now have you studied this before? Have you studied this, what I'm saying? Yes or no? Not in the lectures? You have studied or not? No, officially. Have your teacher talked about moment generating functions? It means that you have seen it, okay? What can I say more than that, okay? So it means that because I was thinking I'm jumping ahead, but I'm not, yes? That is what you're supposed to know. So what is the idea of moment generating function? If you see the table at the very back of your book, you see that you have some information about moment generating functions, but all of them are characteristic functions. But you can imagine, you can pretend that all of them are moment generating functions. And this is unique. So it means that if you look in your list, one of those moment generating functions matched with what you found, there is a theorem, which was not proven in the book, it guarantees you the distribution of x is the same distribution of that particular random variable. Is that right? Yes or no?
Yes.
Okay. I think it is good if you have the formula available, it is good to go to the back. But of course the back thing, I don't know, I think Lucas has also put something. If you go at the back, every time, instead of e, you have e to power it, because they are talking about characteristic function, but pretend that is e to power t. And I want to see, can you detect which one of those have this form? Which one of those has this form? It's Bernoulli. Yes? Can you read the Bernoulli one from the table for me?
The moment generating function.
So by the way, what is Bernoulli? Bernoulli is a discrete random variable taking two values, 0 and 1. Okay? So it is called Bernoulli with p, yes? And you know that p should be somewhere between 0 and 1. Yes? So can you tell me what is the generating function? If you don't mind, let me write Bernoulli p, not to get confused here. Can you read it for me, please?
The moment generating function.
Yes, but pretend that is e to power t.
Q plus p.
Q plus?
E to the power of t.
Yes.
But Q is defined as
Yes, and then you know that in Bernoulli, what is q?
1 minus
1 minus p. Okay, so if you don't mind, let me clean it and write 1 minus p here. Okay? So this is what you got in the back. Now, can you see the similarity between this and that? Yes or no? Okay. So, if you have, there is a theorem that guarantees that if the moment generating functions are identical, that the random variables are also having the same distribution. Yes? Is that right? So, if I do that, by the way, we have to be able to calculate this. Apparently you haven't done these things properly, but let me try to calculate this one for you later. But this is the logic. You calculate it, and then compare it with one of the ones in the end, and then read the distribution. That's the idea. Okay? So can you claim, there is one problem here, you have to be careful. Can I immediately jump into the conclusion and say that, oh, this x is Bernoulli? So can you tell me, so what is the conclusion you want to make? Can you tell me? This one is in the book. This one is what I got. Now we want to put them together, and I want to write x is, what do you write in front of this? Because that is, they are asking this question. You need to write x is what? How is distributed? You realize Bernoulli C. Yes? Yes or no? Okay, but if you're a mathematician, that you are, you have to be, you shouldn't be able to sleep well, you know? That's the whole point. So Bernoulli C has a big problem. What's the big problem? Because Bernoulli P generating function, you know P is between 0 and 1. So I cannot jump into the conclusion and say that X is Bernoulli, and then you say the faucet and this is correct, you become happy, but you shouldn't be happy, first of all, because you have to be careful, yes? So how can I solve that problem? So if in order to conclude this, there should be something told to me, and then I have to know somehow that this C is between 0 and 1. If that is not the case, even though I really like it and say this is Bernoulli, then I don't have right to do it. Is that understandable? Everyone understand what I'm saying or not? Yes. Okay, but how can I know that C is indeed between 0 and 1, even if it is not mentioned directly in the problem? So that is also part of the solution. If you don't do that in the exam, of course you will lose points. And I hope that you agree with me, yes? Because if it's going to be Bernoulli, Bernoulli has this parameter between 0 and 1. So you have to confirm that this is indeed the case. Now, let us go back and finish the problem. Can you tell me why? Can you tell me why C should be between 0 and 1? So, claim C has this problem. What? Extremely simple explanation. Be careful, this is for all. Okay? So when you say for all, what can you conclude? So when I say for all n belongs to n, then what happens? Sorry, this is equal to this one. When it is acceptable for every n, what can you say about this? Do you agree that this one is also correct? Because this is valid for every n. If n is 1, that is also correct. Okay? But what can I say now? It's C. But okay. But this is also valid for what? 2. Yes? So this means that E of x2 is also C. Yes? From here, I can conclude half of it. Do you agree? Because x squared is non-negative. Expectation value of non-negative random variables is positive. Why? So if you don't know why, you shouldn't accept it from him. Yes? So why? Yeah?
Well, because all the values are positive.
Okay, so in principle, it becomes integral or sum x squared probability distribution. Probability distribution is always non-negative. If x squared is non-negative, so the sum is non-negative. So this means that C cannot be negative. Yeah, so this is half of it. But how can I conclude that C has to be less than or at most equal to 1? Variance, you said? Yes, very good. Variance we calculate, yes? So variance of x is equal to what? Yes? But let us calculate. What can I write here? C. What can I write here? C to power 2. So it becomes C times C minus C times 1 minus C. But variance is positive or negative, or we don't know. Variance is positive. Yes? Why?
C is larger than 0.
It's defined by the expectation value of x minus ex to power 2. The real definition. This is derived definition. Yes? But of course, there is also another theorem that you know that this is always greater than that one. So anyway, this is non-negative. Okay? So this means that C times 1 minus C is greater than 0. But here we learn that what happens, C itself is non-negative. So this means that 1 minus C should be non-negative. So then it means that C is less than 1. So now combining together, we have C between 0 and 1, and then we can sleep well, yes? So now, yes, that conclusion is correct. X is the Bernoulli C. Is that right? Okay. So let us see what else we have. Okay, so that's also now we go to the lecture notes. So the lecture notes is this. So problem 581. I hope that I'm not mistaken. 1. Yes. Okay, so this is about Pascal distribution. Pascal n and p, and then n 1, 2, 3 infinity, and this is between, this parameter is between 0 and 1, and of course q in the what I want to say is always 1 minus p. And they have told you that this is the probability distribution, but Pascal, it is clear that it should be discrete. So this is pxk. I'm just writing the question. All these problems are in the question itself. I don't even know why they have given this piece of information. That's the same thing. And they have mentioned that this is equal to k minus 1 choose n minus 1, and then p to the n, and then you have q to the power of k minus n. And then k does not start from 1 or 0, it starts from n plus 1, n plus 2, etc. Okay, before looking at the problem, do you think it makes sense? I'm just reviewing this. Do you think that it makes sense to talk about the the probability generative functions of x? Does it make sense? I want to refresh your memory. Yes, because x is discrete. Okay? And then you need to know how to calculate this. We are supposed to show that this one is equal to pt divided by 1 minus qt, and then totally to power n if absolute value of t is less than q to the power of minus 1. Okay, this is what we want to prove. So, do you remember, if I want to prove something, what is my starting point? What do you think I will start from? No, this you should tell me in 1 second. Definition. Okay? What are you thinking about? We have to start with the definition. Okay? So, g of x of t, what is the definition? Either you remember it or you look it up, but you need to know to start from definition. You don't have any other choice. Okay, so what is the definition? Do you remember? It is this t to power x. Okay, so then how should I do that? Because I know that this x is discrete, so I don't go for integrals, I go for sigmas. So I will write sigma. And then this x is a Pascal distribution. What are the values that my Pascal distribution takes? Are k, it is given in the problem. So instead of t to the x, I write t to the k values, but multiplied by the probability distribution for the random variable this k. I should run it for all possible k values, which is, according to the problem, starts from n and goes up to infinity. You see, this should come in matter of seconds for you. But the rest of it, I agree. That is the hard part of the problem. The rest of it, you should be able to think. So, how do you think I will go forward? So, first of all, I take this out and put my formula there. Okay, so this becomes sigma. K goes to infinity, t to power k, and then what do I write instead of this? My formula, k minus 1, choose n minus 1. And then I have p to power n multiplied by q to power k minus n. So this is at the level of definition, but you see that the problem asks me to find that this one is equal to this expression. And you see this in this expression, there is no track of sigma. So it is already telling you what to do. Try to get rid of the sigma. Okay, so you have to be a little bit good in calculus. This is not a big problem here. Okay, first of all, if you want to manipulate this, I hope that you can see that. Let us get rid as much as we can. Can I get rid of this p to the n? Not get rid of, I mean inside the signal. Can I get rid of it? No, I don't mean throw it out, yes? So yes, this depends on p and n. The counter depends on, the counter name is k. Don't get confused here. The name of my counter is k. It is not depending on k. So it's a constant. So I can pull it out from the C. Okay? So this becomes Pn. And then I have sigma. K goes from n to infinity. If you don't mind, let me write it in this way. K minus 1, n choose it. And then I have this t to the k. And then I have q k minus n. Okay, what is the next step? I'm trying to teach you some kind of experience, you know. So you know that most of these series that we have learned in calculus, they don't start from n, they start from 0. So if you have this as a logic in the back of your head, the next step is at least simple. Instead of starting from n, I want to start from 0. And then there is one trick to do that. Can you help me? So I copy and paste p to the n, and then I write sigma, k goes from where? I started from 0 up to infinity, but what is the price that I have to pay? When I deducted n units from these two, to compensate for that change, I have to add n units to every k inside. Is that clear or not? Okay, so what happens? This becomes n plus k minus 1. I am adding n to every k, not every n. Be careful. So this becomes t to the power of what? And then this becomes q to the power of? Yes or no? Yes? Okay. Okay, I want to see how much you get experience. What do I do next? What do I do next? Yes, mathematicians always keep track of what they want to prove. You know, what they want to prove, you should have always go back to what you want to prove and compare. Okay? So far, I am a little bit happy. Why? Because I have p to power n in my formula. Oh, good, I have it. But immediately I become a little bit more happy. What is that little bit more happy now? I can see the same trick. T to power k, t to power n. I can pull t to power n out. Because for the same reason. So what happens? It becomes p to the n, t to the n. And then it becomes sigma k goes from 0 to infinity. And then I have n plus k minus 1, n minus 1. And then what do I have here? I have t to power k, q to power k. But hopefully you agree with me that I can combine them into one product. Yes? Do you agree? And now, because this is pt to power n, if you don't mind, let me write it as this. So I don't know how many of you have seen this in your one variable calculus course. So do you remember we had a formula 1 plus, let me write x. So let me write with different color because that's not part of the solution. So if I have 1 plus x to power n, and fn is a natural number, this is binomial theorem. So what happens? It becomes sigma, k goes from 0 to the n choose k, x to power k. Okay? This is valid, so let me emphasize here, that n is n. Yes? But might be you have asked yourself, do I have something if n is not natural? For example, if n is negative, of course this method will not work. Okay? Even worse, if n is 1/2, it's not even integer. Have you seen it in your one variable course? What is it called? That's also binomial expansion, binomial series. I don't know how many of you have remembered that. So 1 plus x to any power p is equal to 1 plus sigma k goes from 0 to n, and then you have this formula that n times n minus 1 times n, sorry, p. Because the reason we write it like this, because there is no guarantee that p is a natural number, p minus 2, and then you continue p minus k plus 1, and then you divide everything by k factorial, and then you have x to power k. Sorry, this starts from 1. This is the formula which you know it works only if absolute value of x is less than 1. So these are just calculus courses. This is not at this level. I just wanted to. So if n is an integer, of course, this is a special case of this one. You go back to this formula. It terminates somewhere. Oh, sorry. That's it. That's the whole point. If this is integer, it terminates somewhere. But if it is not if it is a natural number, it terminates. If it is not, it goes up to infinity. But absolute value of x would be less than 1. Otherwise, the series does not converge. Okay? Is that clear? So these are the piece of information that you have to know at this level. I want to consider one simple case of it for negative integers. Okay? In this course, negative integers are enough. So let me calculate this one for you. If you don't mind, let me write minus x this time. You will see why. Minus n. So let me expand this. Still, I have absolute value of x less than 1. So what happens? It becomes 1, yes, plus sigma k goes from 0 up to, k goes from 1 to infinity, and then I have, instead of p, I have minus n. So it becomes minus n times minus n minus 1 times minus n minus 2. It continues minus n minus k plus 1 and divided by k factorial. Then I have minus x to power k. Do you agree? Yes? Do you agree? I have this formula. Instead of x in my formula, I put minus x. And instead of p, I put minus n. But I am telling you that n is a natural number, so minus n is a negative integer. Okay? So then what happens, I can simplify this a little bit. This is 1. I have a negative sign here, negative sign here, negative sign. I factor negative signs out. How many negative signs come out? How many terms are there? K. So it becomes sigma, k goes from 1 to infinity, minus 1 to power k, and then this becomes positive n. This becomes positive n plus 1 because I factored the minus sign out, n plus 2, and it continues to n plus k minus 1, and then divided by k factorial, and then I have minus x to power k. Yes? But the interesting is that this minus 1 to power k, because the powers are the same, what can I write? Instead of minus 1 to power k times minus x to power k, I can just simply write x to power k, because minus signs are cancelled. So this becomes 1 plus sigma, k goes from 1 to infinity. And then can you write this with factorials? This is n plus k minus 1 multiplied by the previous one multiplied by the previous one up to n. If I write n plus k minus 1, hopefully you complain, yes? Because n plus k minus 1 should go up to 1, but it goes up to n. If I write this, I have to compensate for that. What do? I divide by n minus 1 factorial, and then of course k factorial is already there. Are you okay with this? Everyone? Yes or no? This is n plus k minus 1 multiplied by the previous one, multiplied by the previous one, up to n. I wrote it factorial, but for factorial I have to go up to 1. So I have to divide by this, which was not there. Is that right? And then I have x to power k. And then let me continue. So it becomes 1 plus sigma, k goes from 1 to infinity. But this is this combinatorial number. It is n plus k minus 1, n minus 1. Yes. This is the formula. If you open this up, it becomes that. So it becomes x to power. Yes. But what happens if k is 0 in this case? If k is 0, this becomes 1. This becomes n minus 1, choose n minus 1, which is 1. So for this case, you don't need to separate 1. Now you can combine them. In general, you have to separate. Okay? But in this case, I can combine them. I want you to understand these things. Okay? So this becomes equal to sigma, k goes from 0 to infinity, and then I have n plus k minus 1 choose n minus 1 x to power k. So the bottom line is this: if n is a natural number, and if absolute value of x is less than 1, what can you see? 1 minus x to power minus n is equal to sigma n plus k minus 1 n minus 1 x to power k. K goes from 0 to n. Okay, so that is your formula, which is called what? Because of that negative n, it is called negative binomial. Okay, I'm not saying that you have to know to deduct these things, but it should look familiar to your eyes, so that when it comes in, you know what to do. Is that right? Okay, now can you help me to do this? Everything is already done. Assuming that you know every green part, you don't need to, I hope you don't need to justify this in the exam. Ask Lucas. Okay? Because these are one variable calculus. Okay? So how can I continue here? This I copy and paste. By the way, do you see the sound of this chart? I have ordered it from Japan, you know? It's a very nice one, yes? It's the best in the world, I think. There was a competition between Japan universities and MIT, you know, because of the chalk. Can you feel the voice, you know? I am enjoying it. You know. So, okay, you compare it with the right-hand side of that formula. Yes? Is it exactly the same thing? Compare this formula with what you have here. The only difference is what? Instead of x up there, you have t here. So you have your formula. So what should I write in front? I should write 1 minus what? My x. What is my x? Qt. Okay? And then to the power of negative n. But be careful. Why this is coming from? You have to understand everything. Because this converges if and only if I respect this condition. So this means that if I want to write this, in principle, I have to check this one, that absolute value of my x is less than, yes or no? Okay, so what is now, this? Do you agree that this means the same thing written in the book? Yes, do you agree? Do you agree or not?
It is.
Yes? Yes, you have to doubt a little bit. Why this is true? No, you have to be very critical in mathematics. Yes? Yes. If Q is not positive, I am not allowed to do that. So you have to see, why is Q positive or not? Yes. Because Q is 1 minus PP is between 0 and 1. So everything there is for a reason. Yes? So you have to be careful in mathematics. And that's the beauty, by the way. So then do you agree that this is the same thing? Yes, I will bring it down and make it positive. So then it becomes PT 1 minus QT to the power of n. Any questions? Okay.
We have this kind of questions in the exam.
What?
Exactly.
About exam, I never studied for exams in my life.
Okay.
I had the worst possible grades except for my PhD, okay? And on my PhD, I became sick, and I actually went to a psychiatrist because there was a course, quantum field theory, which is a very heavy course. And that's very strange in Sweden. Sweden is an extremely nice country, and people are not in hurry. But when it comes to education, they just push the accelerator pedal, you know, I don't know why. That course we had, I was ambitious to get an A, but they wanted to present that course within 7 weeks. And I just want to compare you that course in Harvard University is 3 full semesters, 1 year and a half. Okay? And they would just cram this to us. So that was the first time I saw a psychiatrist in my life, because I'm always happy. And of course, when I grew older, I could have immediately given up. So what's the problem of getting? Of course, I got an A, but I got sick. Yes, but never in my life. And the reason I cared, because I immigrated here because I wanted to find a job. I thought that might be useful to get the postdoc, but then of course I didn't care. Okay, so I actually destroyed my life for a few times. But the point is that I fought with it, and the course form changed in Stockholm University. If you go there, that course is at least a 1 year course now. Not 1 year and a half, but it was much better than 7 weeks. Okay, the problem is that here you don't fight. That's very strange. Yes? So you have to fight. And I just want to make sure that you really understand the value of democracy. Democracy needs care. Yes? Yes? It's very important. If you don't care and you don't take care of your democracy, little by little, it is gone. And I just want to tell you something. When I came here in Sweden, I have heard about that this SL card has a discount. Okay? In my country, it's a different thing. So when I came to the first, I wanted to buy a discounted SL card, and then I told the guy, and then I was looking for my ID somewhere, and I had a lot of bags, and I couldn't find it. I said that I will give you the, and then before even giving the ID, that SL card was issued for discount. I was shocked. So how beautiful is it that you trust me? But 5 years later, even though I was in Lapis, because I was doing my PhD, I was in the student area. Every time, by the way, I'm a little bit old person. Okay? Every time I had to show this damn ID card to actually issue the card. If you are sensitive, you have to cry right away, because the deviation starts exactly right there. Sometimes when I go, I'm just sorry for that, when I go to the toilet, yes, I start more or less literally crying. Yes, you have to be sensitive, because deviation from, what does it mean if there are toilet papers all around the toilet? What do you think? What is happening? It's a very bad thing. The democracy is declining exactly in the toilet. Yes, you think about it, because that paper towel is actually spread around by some behavior of a human being. Yeah, you have to cry. I just want you to understand, because you don't believe in that. I mean, this mullah regime actually destroyed my country. Of course, I don't think there is one single country more civilized than Sweden, but still, it can be easily destroyed if you don't take care of it. Yes? I really want you to take care and be sensitive about this. That's a little bit bad thing. I mean, from this perspective, American universities are a little better, of course, before this Trump. But, but these kinds of, do you really sit down, because I was teaching in high school for 8 years, they didn't even talk about these things. So if you don't value CSN, can you even feel what is the meaning of having CSN? Of course, it is not a free money, but it shows the civilization of Swedish people. Of course, every country is getting taxes. Why it's not free everywhere? This is the level of civilization. It means that we people decided to put this money for healthcare and education, and even higher education. Countries like Germany still fighting for CSN, something like that. Yes? So you have to value these things. If you don't value it, strong. Yeah. I just want you to think about it. So work hard. Yes? You have to be enthusiastic. So, I mean, I don't know, I couldn't finish this. If you don't mind, tomorrow I will start continuing these things, because apparently you haven't studied these things very well. But I have requested for extra lessons. But they haven't talked, I mean, they haven't actually responded to me. Yes, but I will go to Tommy again.